Hi everybody, Mr. Rubo here. We're continuing with topic 1.5. We are now looking at complex roots here. So some polynomials have roots that contain an imaginary number. Imaginary numbers, because these our coordinate planes are made up of just real numbers, they won't show up on the graph as x-intercepts. Okay, so here this means that we will not see them on the graph. So nice easy example here. We have this graph of x squared, so we got that quadratic plus 1, so it's been shifted up compared to the normal one. Okay, if you want to find the zeros, just like whether they're complex or real, you just set it equal to 0 and you solve, right? So you can kind of see the solving here. Subtract the 1, square root both sides. Because we square root, we put the plus or minus. Square root of -1 is I. So here we actually get two complex roots, both imaginary, and we have a plus I and a minus I. Okay, so there's our two roots. And you'll notice we have no x-intercepts. So big thing, there's kind of a couple things. One, whatever the degree is of our polynomial, that tells us how many zeros there are, how many roots there are in general, okay, real and imaginary. So in this case, because it was x squared, I knew I had to have 2, okay, but I had no x-intercepts, which means they both had to be imaginary, okay. The other thing that's actually really kind of interesting with complex, with these imaginary zeros, is all imaginary roots come in pairs. Okay, so what that means is if you get a plus bi is a root of f of x, so if you are just told that, you also get for free that a minus bi is also a root. These are what we call conjugate pairs. Okay, conjugate is when we switch the sign, so it was a plus, now it becomes a minus. But everything else stays the same. So if a was -1, a is still -1. B was 1, b is 1, but now we're subtracting it, so that sign does change. Okay, but yes, they always come in these conjugate pairs. So again, if you have an x to the third power, or degree 3 polynomial, you know that there should be 3 zeros. If you have one real, the other 2 have to be imaginary. Okay, you'll never have just one imaginary 0. Always comes in pairs. All right, cool. That's it for today's video. Thanks for watching and have a good day.